Okay, hi guys, this is my video on the booklet 2 of the revision notes. So that's what we are going to be discussing today, and this pertains to chapter number 3 and 4 of the core reading, right? So these two are the chapters that are covered in this booklet. And before we start it, the first thing I want you to do is before we start any booklet of the revision notes, this is like a must do. You should go to the end of that booklet and there is a section called as, let me find out the name, it's called as fact sheet. Okay, there's always a section called as fact sheet given on the end of your revision notes. It just states all the concepts from the chapters that are covered. They're just given there, and you know before you start the questions you should always revise those concepts so that they're fresh in your mind and everything there seems obvious to you. If everything there doesn't seem obvious to you, you should go back and you should watch my videos pertaining to that particular portion again, because unless those things are really obvious to you, you won't be able to solve these questions. So first thing to do is be referring to the fact sheet. Now let's just start with a few questions from the booklet. I'll only be discussing the tricky and complicated questions. Other questions are pretty straightforward, and if you struggle with them, look for the solutions or just message me. Okay, so I am starting with question number 10 here, and it says that a select life aged 62 exact. Okay, so there is a select life that is age 62 exact purchases a 3-year endowment assurance. So we got an endowment assurance contract being purchased by a life age 62 years with a sum assured of £100,000. Premiums of 30,000 are payable annually in advance. So they've told us the amount of sum assured as well as the amount of premiums, and they're payable throughout the term of the policy. So or until earlier death. So we have got these premiums that are payable in advance for 3 years at the beginning of these periods, and obviously it would be a temporary annuity due because they are payable throughout the policy term or until earlier death. The death benefits is payable at the end of the policy year of death. Okay, calculate the EPV of profit or loss to the office on the contract using the following basis. Okay, so we need to calculate the expected present value of the insurer's profit or loss. Okay, we would be doing it for let's just do it for loss, or should we do it for profit? I'll check the answer that is given at the end of the, the revision notes. I'll check what they have given. Okay, they have given the answer for profit, so we would be doing it for profit. You can also do it for loss. Okay, and the problem with this question is the reason this is not very straightforward is because they have not given us a particular table to refer to. Okay, they have not specified AM92 or ELT15 or things like that. Okay, they have not specified these tables. Rather, what they have done is they have given us the interest and the mortality separately, and these are basically the mortalities that are given. And okay, there is a selection involved here. So how does the selection work? The selection is for 0, 1 and 2 years. Okay, so there are basically there is a 3-year selection period at time 0, time 1 and at time 2. Okay, and this is how we would be calculating the select Q values. Okay, okay, so this makes a lot of sense. Let's just start with this question and we'll see what is happening here. So I'm gonna take a orange pen. Okay, so we know the EPV of loss or the EPV of profit is basically equal to the EPV of the inflows minus outflows, because if inflows are greater than outflows we'll have a profit, so it would be equal to the inflows minus the outflows. Okay, or simply speaking, as there are no expenses are to be ignored, it would be EPV of EPV of premiums minus the EPV of the benefits. Okay, so that's what we gotta do. Let's find out the EPV of premiums. Now, the amount of premium is given as 30,000 per annum. So it's 30,000 pounds payable per annum into the annuity factor, that is a temporary annuity due payable to a life age 62 for 3 years. Okay, and this is obviously select. Okay, now the challenge is to calculate this using these things. Okay, so this is just, let's see what it is. This is just 30,000 into this factor. Okay, so this is a temporary annuity that is payable in advance. Okay, so the payments would obviously start at time 0, right? So this would be sum of k going from 0 to it would go up till n minus 1, right? So till time 2, 0 to n minus 2, v to the power of k into kpx, right? All this is saying is that if there would be a first payment, that would be discounted by a factor of 0. The second payment would be would occur if the person survives for 1 year, that is at k is equal to 1, and then it would be discounted by 1 year, and then the third payment would be discounted for 2 years, and it will happen only if the person survives for 2 years. Let me explain this by expanding this. So this just becomes this thing. Obviously, x is select here. So this just becomes 30,000 into v to the power of 0 into 0px, that is just 1, plus v to the power of 1 into 1px plus v to the power of square into 2px. Okay, so this is what I have here. It's a simple factor. Now let's just find out these values. So this would become just 30,000 into 1 plus v to the power of 1 would be let's keep it v to the power of 1 for now. This would be 1px, this would be v square into this factor can be written as person aged x surviving for 1 year into the person aged x plus 1. Okay, because selection still lasts, surviving for 1 more year. So I just need these values. Okay, I just need these values, and x is basically equal to 62. So what I need is px, that is equal to p62. That is the first thing I need. Okay, and p62 is basically equal to, it is equal to 1 minus q62. Okay, it is equal to 1 minus q62, and q62 would be equal to, we can find this using this definition here. Okay, it says that qx minus t plus t is equal to 1 upon 4 minus t qx. Okay, so this just becomes 1 upon 4 minus 0, since this is the same as 62 minus 0. Okay, so 1 upon 4 minus 0 is 1 by 4 into qx. So qx is q62, that is 0.018. So this just becomes 0.0045. So this is the value of q62, and thus p62 becomes P62 is 1 minus 0.0045, that is 0.9955, right? Okay. Next thing we need is obviously P62 plus 1, so that is P62. Let's divide this section. P62 plus 1 is equal to 1 minus Q62 plus 1, and the value of Q62 plus 1 is given by the same equation that is given in the question. So Q62 plus 1 would become, now the value of T would here be actually 1. It just becomes 1 over 3 into Q63, right? Because the definition says that we have got, it is 1 upon 4 minus t, so t is 1, so 1 over 3, and qx. Now here x is obviously since x minus t is equal to 62 and t is equal to 1, so x becomes 63, right? So I've got q63 here, and this comes out to be 0.00667, right? And thus we've got, because this was 0.02, okay, that's given in the question, so this comes out to be 0.0067, and thus your P62 plus 1 value comes out to be 0.99333. Okay, and that's the value. Okay, and what more do I need? I don't think I need anything else, so let's just evaluate this here. Okay, so this just becomes 30,000 into 1 plus V1 is 1.075 to the power of minus 1. Okay, because 7.5% interest, this becomes as we calculated 0.9955. Okay, plus 1.075 to the power of minus 2 into this thing is again 0.9955, and this factor, it becomes, as we calculated just now, it was P62 plus 1 would is 0.99333, so this just becomes 0.99333. Okay, and this value, it comes out to be, your EPV of premiums comes out to be 83452.18. Okay, so that's just your value. Right. Okay, moving on to your EPV of benefits. That's the next thing we need. So that's just the assurance contract was endowment assurance, right? So endowment assurance of 100,000. Okay, let's just check the question. 3-year endowment assurance contract. Okay, so endowment assurance is term assurance plus pure endowment, right? So this just becomes your term assurance, that is AX13 plus the pure endowment AX31, right? And if I try to evaluate this just becomes 100,000 into, this is obviously sum over k going from 0 to n minus 1, that is 2, v to the power of k plus 1 into k deferred qx, right? That's your definition. And this is obviously payment on survival. So if a person aged x survives for 3 years, there's a payment of v to the power of 3. Okay, so that's your payment. And if I try to expand this, this will become 100,000 into let's expand this, v to the power of k plus 1 becomes v to the power of 1, because the payment is at the end of the first year, and k deferred qx, that is 0 deferred qx, so that's just q 62, that was the age, right? Okay. Then I've got plus v to the power of 1 plus 1, that is 2, into 1 deferred qx, so that is 1 deferred q62, okay, plus the final payment, that would be v to the power of 3 into 2 deferred q62, plus this factor, it just becomes v to the power of 3 into 3px, that is 62. This is this factor. Okay, so now let's just try and expand this and find the values that we need. So this is just 100,000, and this is v to the power of 1, this is q62 obviously, into plus v square into the and now this is a deferred probability of death, so it would be probability that a person age 62 survives for 1 year, and then the probability that person age 62 plus 1 dies within 1 year. Okay, plus v to the power of 3 into 2 deferred, so I've got a probability that a person aged 62 survives for 1 year, then the probability that a person aged 62 plus 1 survives for 1 more year, and then this person dies at the age of q 62 plus. Okay, so this is what I have here, and this one, this just expands to v to the power of 3. If I try to expand this, this is p62 survives 1 year, p62 plus 1 survives 1 more year, and p62 plus 2. Okay, and now if you will observe this, these two terms, they have this factor common, so I can just add them up. I can just take it common and add them up. So these two factors, they will add up, p62 plus 2 and q62 plus 2, and they will add up to 1. Okay, so I'm directly writing these two as 1, so they just go away. So I'm taking these two common and writing that factor as 1. So this just becomes 100,000 into v to the power of 1 into q62 plus v square into p62 into q62 plus 1 plus v to the power of 3 into what I have taken common is p62 into p62 plus 1, and inside I just have this plus this factor, right? So I've got a bracket in q62 plus 2 plus p62 plus 2, so they just become 1, and so I can just ignore them. If I don't write them even, that will be fine. So these two just become 1, right? Okay, now this is what I have here. Let's just find the answer. This just becomes 100,000 into v to the power of 1 is 1.075 to the power of minus 1 into q62, as we found out the value earlier, this was 0.0045, okay, plus 1.075 to the power of minus 2 into P62 is 0.00, no, it is 0.9955 into Q62 plus 1 is 0.00667. Okay, this is what I have, plus v to the power of 3, that is 1.075 to the power of minus 3 into this factor. These two are just P62 and P62 plus 1, so they just become 0.9955 into 0.99333. Okay, we have calculated these two. So that is all for your answer. So this is your final answer, and this just becomes, this is equal to, your EPV of benefits is 80592.52. Okay, and your EPV of profit becomes the EPV of premiums minus EPV of profit is your EPV of premiums minus EPV of benefits, so that just becomes 83452.18 minus 80592.52, so it just becomes pounds 285966, okay. So that's your answer. That's how you solve such question. So I just applied the first principles and definitions directly instead of using some tables, and that's why you must have gotten confused with this question, but there's no big deal about it. So we'll move on to the next question now. Okay, so the next question that we solve is question number 13, and this is a pretty straightforward question, but I got a doubt from someone on this, so I am solving this. Otherwise this is pretty straight. Okay, so we need to use the assumption of CFM, that is constant force of mortality, and calculate this value Q 0.5 Q 72.25. Okay, so I am calculating 0.5 Q 72.25. Okay, so this can be written as 1 minus 0.5 P 72.25. Okay, right? And I can just write this as, now what I need to ensure are two things. Okay, x, this x has to be an integer. Okay, and this t, it has to be either an integer, or if it is some what do we call it, some non-integer value, it has to be between 0 and 1. Okay, so that those are the rules for x and t in order to apply CFM or UDD or any other assumption. So I've actually told you these two rules, so we need to convert these two somehow, so that t is between 0 and 1 and x is an integer. Here t is between 0 and 1, but x is not an integer. So what is happening here is, in order to make this x an integer, I need to apply some sort of adjustment here. So how will we go about that? Let's see. Okay, let's say we know that probability going from 70 to 0.75, this thing, this would be equal to, see, if I'm going from age 72 to age 72.75, how can I go with that? I can actually go first from 72 to 72.25, and then I can go from 72.25 to 72.75. So I can basically write that this entire thing, that is P 0.75 P 72, is equal to the probability of going from 72 to 72.25, that is 0.25 probability P72 into going from 72.75 to 72.25 to 72.75, that is 0.5, that's the difference, P 72.25, right? So I can write this as this, and this is the thing that we have got here. We have got 0.5 P 72.25, and the problem with this is that this part is not it is not integer, but these two are okay. This and this, they are integers, right? So I can actually adjust this, and I can write this in the form of these two, where we have got integer, that is 72, and both of them in case of both of them, t is between 0 and 1. So I'll write this term as in the form of these two. So this would imply that 0.5 p 72.25 is actually equal to 0.75 p 72 divided by 0.25 p 72, right? So I can write this as this, and I'll do the same thing here. So this is just 0.75 p 72 divided by 0.5 no 0.25 p 72. All I'm saying here is, if I divide this path by this path, I will get this one. Okay, I've just taken this entire path from 72 to 72.75, and out of this, by dividing, I've removed this portion till 72.25. So I'm just left with this, going from 72.25 to 72.75. So this is just a path of 0.5 that's left. Okay, so this is the adjustment that we follow here, and now I can apply the CFM assumption. So that says, CFM says that TPX is equal to T is equal to PX to the power of T for all T's that are between 0 and 1, right? That's what your CFM assumption says. So this just becomes, this one becomes P 72 to the power of 0.75 divided by P 72 to the power of 0.25, right? So that's how I convert these two, and this just becomes 1 minus, since the power of the same things are here, I can just adjust them, so it just becomes P72 to the power of 0.5. Now I just need the value of P72 from the PMA tables. Okay, so the PM92 base tables are given on page 110 of the table. So let's browse them and check the value of P72 there. So let's find it out. Okay, here you go. Okay, so this is page number 110 of the tables, and for 72 Q72, I have the value 0.30732, right? This is your Q72 value. So for a P value would be 1 minus this. So this just becomes this would become, wait a second, this would become 1 minus, okay, 1 minus the Q value, that is 0.030,732. This is your value to the power of 0.5, right? So this just becomes 0.5, and if you calculate this, this comes out to be 0.015486. This would be your final answer for this question. So that's how you go about doing these things. Okay, and that's your answer. Okay, next is question number 19, and this is probably the most interesting and a bit tricky question from this booklet. So I remember struggling with this a lot. I hope I am able to explain this clearly to you guys. Okay, so a gymnasium offers membership. Okay, so gymnasium is offering a membership for 3-year period at a fixed fee of rupees 240 per annum payable monthly in advance. So 3-year membership is there, and the fee is payable monthly in advance. Okay, the contract may only be cancelled at renewal anniversary. So here people are not dying. Instead, the contract may be cancelled. So if the contract is cancelled, the annuity would basically stop. Okay, the monthly premium cease immediately on death of the member. So there's a death clause too. As soon as the person dies, the premium cease, and basically there is a renewal too. And if they don't renew, the premiums will go to, and if they die, then also the premiums will stop coming. So there are basically two kinds of decrements. When you'll study chapter number 10, you will find a term called as decrements. So there are basically two decrements operating on this population. That decrements means any force that is acting to kick a person out of the population. Okay, so this you will study in chapter number 10, competing risks. That uh, there can be more forms of decrements such as retirements, marriage, things like that. Okay, so here the decrements are cancellation as well as death. Okay, and calculate the EPV of the membership fees if the gymnasium sells 120 memberships. So let's just make a diagram and try to find out what's happening here. Okay, see, we are receiving a certain amount of membership fees. This is the timeline. We're receiving a certain amount of membership fee over 3 years. Time 0, time 1, time 2, time 3. Okay. So these are basically the times. And we are receiving 12 installments of these membership fees every year. And as soon as a person dies, they cease then and there. So if the person dies at time 0.5, that is after the end of 6 months, he has only paid the first six installments, first six monthly installments. And if the person survives for let's say 1 year and 2 months, he would have paid only 12 plus 2 14 installments so far. Okay, and that's how it works. Okay, so as soon as a person dies, he would stop paying this annuity to us. This is in form of a annuity that is payable in advance. That is what they have told us. Okay, fixed fee of 240 per month payable in advance. That is why it is an annuity. Okay, and it ceases immediately on death of a person. Also, there is one more clause here. One more clause here is that at the end of every year, um, at the end of every year, the contract may be cancelled. Okay, so this is they're saying the contract may be cancelled at each renewal anniversary. So at the year of end of year 1 or year 2 or year 3, the contract may be cancelled. Okay, and then the person would also cease paying the annuities. Okay, so that's how it is working. And they have given us the rate of interest as 6% per annum, and the rate of mortality is 1% per annum. Okay, so there is a mortality of 1% per annum, and the probability of renewal is 80%. So 20% of the policies will cancel each year, and there are a total of 120 memberships. Okay, so we need the EPV of your of the payment. Okay, so your EPV, if I try to calculate, what I'm going to do is I'm going to divide this term into 3 years. Okay, so if I want to calculate the EPV of the first year's subscription fee, it would be equal to the sum of these 12 payments, and basically it would be equal to A due. Okay, there is no cancellation in the first year. The first cancellation would occur after the end of first year. So I don't care about the cancellations. All I care about is the mortality. So it would be A due um, X, whatever the age of the people is, for 1 year, and there are 12 payments, right? Okay. So in order to calculate this value, it is the same as A due X 1 minus. Now I need to convert this into 12, basically 12 payments, right? Because monthly payments are happening here, so I've got this 12. So it just becomes uh, since this value would be smaller than this value, we know these are monthly payments and this is one annual payment, as I have already taught you. So this is minus, and since we are converting the same thing, so it's m minus 1 upon 2. So this just becomes 11 upon 24, that is 12 minus 1 upon 2m. Okay, that is 24 into, since the adjustment would be at the first payment as well as the last payment, so I've got this factor into 1 minus v to the power of 1 into 1 px. Okay, these are the factors that I have, and if I try to evaluate this just becomes this factor would be 1, because all this is saying is a certain payment, one certain payment of £1 in advance. Since this is occurring at time 0, there would be no discounting factor multiplied, okay, or no probability of survival, since this is not dependent on the survival of the person. So this just becomes 1. This is a certain payment at time 0, and this becomes the EPV becomes 1. Okay, this becomes 11 upon 24, and this part it becomes 1 minus v to the power of 1 is 1 point. What was the interest rate? It was 6%, 1.06 to the power of minus 1. And probability that X survives for 1 year, the mortality was 1%, so the survival probability would be 0.99, right? So this is the factor that I have, and the value comes out to be 0.96973. Okay, so this is your value for the first year's payments. If I talk about the second year's payments, it would be, let me call it EPV of premium Y2. Okay, let's call it the EPV of the subscription in the second year, at the beginning of the second year. Okay, so if I were to calculate, it would again be the same thing, because it's just 1 year's payment. Okay, and again the factor is 11 upon 24 into 1 minus v to the power of 1 into 1 px. So exactly same things will operate, as the mortality is also same and the interest is also same and everything is same. The only change would be that this would be multiplied by the number of people which are alive, which remain in the population now. So 20% people surrender the policy and 80% people renew, so there would be a factor of 0.8. Now some of the people would have died throughout the first year, so there would be a factor of 0.99, and also this would be discounted for 1 year to get it to the beginning of the first year. See, what we did here was, I was talking about the subscription in year 2, that is between time 1 and time 2. Okay, so with this factor, what I did was I took all these 12 subscriptions and I brought them to time 1. Now at time 1 only 80% of the people remained. So in order to take it to time 0, I have to multiply it with this 0.8. Then I have to adjust for the probability that the person survive from time 1 to time 0 to time 1, right? That is 0.99. And then I have to adjust for 1 point, the discount, because this is obviously being discounted, the interest for the first year, so 1.06 to the power of minus 1. So this factor turns out to be the same, 0.96973, and this one turns out to be 0.8 into 0.99 into 1.06 to the power of minus 1. Okay, similarly in the third year the results would be similar, so I'm going to add up all the possibilities here. So I've got 120 people paying up a 240 per annum subscription into first year it would be 0.96973 plus in the second year it would be 0.96973 into 0.8 into 0.99 into 1.06 to the power of minus 1, and in the third year it would be 0.96973 same into they will have to stay in the population for 2 years, so renewal probability for 2 years is 0.8 square. This would be 0.99 square because they'll have to survive for 2 years, and this would be 1.06 to the power of minus 2 now. So this is how it works, and if you will evaluate this, this would come out to be 64,387 pounds, and that is your answer for this question. So I hope this is clear to you guys. Okay, so the next question is question number 27. So it says define 4 deferred 5 Q60 plus 1, okay, in words. So we need to define this probability in words. So this is just the probability of a person. Let me write the definition for you. Probability of a person aged 61, the current age is 61, who entered the population at age 60. 60 select, okay, because he entered the population at age 60, and thus we have got 60 in bracket plus 1, right? So selection age was 60. So it's the probability of this person dying. He has to first survive for 4 years because there is a deferment of 4. So first he has to survive for 4 years, so he has to dying between age 61 plus 4 is 65, and then he has to die within the next 5 years, because this just means P 60 plus 1 4 into Q 65 5, right? So he has to first survive for 4 years, so he has to die between age 65 and 65 plus 5 is 70. So this is what this probability means, right? Now if I were to calculate the value of this probability, the definition is pretty straightforward. This just becomes they are asking us to calculate this using the, I think, the AM92 mortality. Let's check which mortality is to be used. Okay, AM92 is the mortality. We don't need the interest. So AM92 mortality, this just becomes L, since the selection period is only of 2 years, this becomes L 65 minus L 70 over L, the current age is 60 plus 1. Okay, so that's what it becomes, and this is the definition for the deferred probabilities, deferred dying probabilities that I had given you. Alternatively, you can put the values of these two individually, then multiply them, so you'll get the same answer, but this is the easier way to do this. So L65 is just 8821.2612 from the tables, minus this is 8054.0544. These were two ultimate probabilities, and this fellow here, it is just the second column values, that is um, this probability x minus 1 plus 1, and you will find this against the age 61 and not 60. So this becomes, this is this value, the second column value against 61. Okay, because ultimately x is 61, so I need x 61 minus 1 in the bracket plus 1, so 61 minus 1 is 60, right? So this is the value in front of 61, and this becomes 9209.6568, right? And the answer for this comes out to be 0.8308, okay, 0.083305, right? So this is your answer. Okay, this is another pretty straightforward question, and this was asked by one of the students. I don't know why she had a problem with this, but this looks pretty straightforward to me. So let's just evaluate this. This is asking us to evaluate A5015 um, for 6% per annum interest from AM92. And we know something here. We know that A due 5015, this value is already given in the tables. Okay, so if you need A5015, you take advantage of the fact that 50 plus 15 is equal to 65. So this value is already given. Okay, this value, what we do is we subtract a 1 with a factor of now we need an adjustment with this at age 50 as well as at age 65. We need adjustment at time 0 as well as at time n. So minus 1 would be there, and this would be multiplied with a factor of 1 minus L65 over L50 into v to the power of 15. Okay, so this is pretty straightforward here. Now let's just take these values from the table, and if you will put these values from the table, I'll take. Let's find out the value. See, okay, 6%. I've got these sum to 60, and 65 should be on the next page. This is page number 107, I think, of your tables. Yes. So page number 107, 5015. We need the value of A5015. So it is just A due 5015 is equal to 10.038, right? So this is 10.038. 10.038 minus 1 into 1 minus L65 over L50 is equal to, from the tables you can check this value, this is equal to 8821.2612 divided by, this is 9712.0728. Okay, and this is V15. This is 1.06 to the power of minus 15. And if you will solve this, you'll get the answer as 9.417. So this was a very easy question. Questions cannot get easier than this. You should be like super happy if this comes in your exam. Okay, so that's all. Okay, so the next question that we discuss is question number 29, and it says that calculate the constant force of mortality applicable to a life aged between 67 and 68. So there is a life aged between 67 and 68, and I have to calculate the CFM, the constant force of mortality, that is the force of mortality if it was a constant, okay, based on AM92 ultimate mortality. So the way to go about this is I have to actually assume constant force of mortality first. So my TPX value, that would be, my TPX value would be e to the power of minus integral of going from 0 to 1 mu dt, right? This would be my TPX value, because now I have taken mu as a constant. Usually this is e to the power of minus going from 0 to 1 mu x, this is TP1, okay, this is TP1. So this is usually minus 0 to 1 x plus t, right, dt. But now since this is a constant, it just becomes mu. So it is a constant here, so it becomes e to the power of, if you integrate this, this becomes e to the power of mu t going from 0 to 1, okay, and this just becomes e to the power of minus mu if you put these values. So this is your value for TPX. Now this TPX would be equal to the TPX value from the tables. Okay, so this is just PX from the tables. That is this is equal to P. The age is 67, right? So this is equal to P67. So this is equal to 1 minus Q67, which would be equal to 1 minus the value from the tables, if you check it, is 0.017824. Okay, this is your value for it, and this just becomes 0.982176. Okay, so this is your value for TPX, right? So if I equate these two, if e to the power of minus mu is equal to this, so the value of mu comes out to be, taking a log on both sides, it comes out to be 0.0178985. Okay, so this is your value for the mu quantity. Okay, this is your constant force of mortality. Now they are telling me that I have to use this constant force of mortality in order to calculate this value 0.5 cube 67.25. Okay, calculate the value this under the assumption of constant force of mortality. Cool. So this becomes 0.5 q 67.25. So this is just 1 minus 0.5 p 67.25. Since this is a constant, this just becomes 1 minus e to the power of minus mu, that is your TPX value, to the power of 0.5, right? Because this would be a constant throughout. Applying the CFM assumption directly, or you can convert this into the p probabilities like I did in one question before. You can say that and you can convert it like that. You'll get the same answer. So this just becomes 1 minus e to the power of the mu value is minus 0.17985, and this to the power of 0.5. So this just becomes the answer comes out to be 0.99, okay, 0.00895. So this is your answer for this question. Okay, so the next question is question number 30, and this is what we are gonna solve now. Let's start with this. This says that an endowment assurance contract with a term of 10 years pays a sum assured of 1 lakh pounds, that is 100,000 pounds, immediately on death, and a sum of 50,000 on survival to 10 years. Okay, so if the person dies, there is a sum of 10,000 payable immediately on death if he dies within 10 years, and if he survives till the end of the 10 years, the sum is 50,000. Calculate the EPV and the variance. Okay, so the first thing we calculate is the EPV. So we have to and they have given us mortality as, they've given us a constant force of mortality, and they've given us a rate of interest. Okay, so they have not specified a table, so we have to apply the first principles here. So the EPV would be 100,000, okay, into a immediate, because the payments are immediately on death, a immediate, the age is not given, so x and 10, okay, and there's a 1 over this, so a temporary annuity payable immediately on death of 100,000 plus 50,000 pounds on survival. So this is the this is multiplied by the probability that a person aged X survives for the next 10 years, and this is discounted by a factor of 10. Okay, V10. Okay, so this is what you have. Let's just evaluate this. This is 100,000 into going from 0 to 10. If the person has to survive for T years, so TPX, and then he has to die immediately, so mu x plus T dt, and this is multiplied by a factor of Vt in order to discount this. Okay, so this is what you have, and plus 5,000 into this is 10px into v to the power of 10. Okay, so this is what you have here. Now let's just try to evaluate it. So this just becomes 100,000, okay, into going from 0 to 10. 10px would tpx would be e to the power of minus, since mu is constant here, it becomes e to the power of minus mu t, and the value of mu is given as the value of mu is given as 0.03. Okay, so this is 0.03 t. Okay, since mu is constant, into mu x plus t. Mu x plus t is constant again, 0.03 into v to the power of t. V to the power of t is e to the power of this is e to the power of minus delta t. That's what I can write this as, where this is the force of interest. So the rate of interest here is given as I is equal to 1 point, it's I is equal to 0.05, right? 5% interest. So if I were to calculate the force of interest, the equivalent force of interest would be delta is equals to the log of 1.05, right? So this is log of 1.05. So this becomes into e to the power of minus log of 1.05 t, right? That's what it becomes. Plus this becomes 50,000. Again, this was 50,000. 50,000 into 10px is e to the power of minus 0.03 t, and this is just v to the power of 10 is 1.05 to the power of minus 10. Okay, so that is your answer here, and let's just simplify this and get the final answer. So this just becomes 100,000 into this is 0.03 comes outside, okay, and the inside thing is going from 0 to 10, e to the power of minus 0.03 plus ln of 1.05, okay, and this is t dt. Okay, and this one is 50,000 into e to the power of minus 0.03 into this is 10, okay, and this is 1.05 to the power of minus 10. Okay, cool. Now this is basically what we have here, and right, so this becomes, if I integrate this, this becomes 100,000 into 0.03, and this becomes if I take the integral of this, this becomes e to the power of minus 0.03 plus log of 1.05, okay, to the power of t divided by minus 0.03 plus log of 1.05, okay, and this is what I have here. This is how I integrate it, and going from 0 to 10, okay, plus 50,000 into e to the power of minus 0.3 into 1.05 to the power of minus 10. So actually now I can put these values here. When I put 10 in place of this, and when I put 1, let's check what it becomes. This is 100,000 into 0.03 divided by 0.03 plus log of 1.05. Okay, inside I've got, I'll put 10 in place of this and 1 in place of this, and I've got a minus sign. So since I've got a minus sign here, let's put this minus sign outside, and this becomes e to the power of minus 0.03 plus log of 1.05, and this thing into 10 minus 1. Cool. So this is what I have, plus 50,000 into e to the power of minus 0.3 into 1.05 to the power of minus 10. Cool. Now let's evaluate this using a calculator, and this would come out to be, this comes out to be 43498.914. Okay, so that's your answer, or you can approximate this as 43499. So the next thing is the calculation of the variance. So the variance is basically equal to EPV square, okay, expectation of the present value squared minus the expected present value whole square, right? So we have got the expected present value, all we need to calculate is the expectation of the present value square. So this just becomes going from okay, we have got two terms here. So we have got two terms here. This becomes 100,000 squared into, going from 0 to 10 tpx into mu x plus t dt, and the interest factor would now be squared, so it would be e to the power of minus 2 delta t, right? That is what we'll have here, plus 50,000 squared into tpx into 1 plus I to the power of minus 10, and this interest factor would also be whole square. Okay, so this is what you have here, and let's just calculate this. This is 100,000 squared into this factor. It would be, if I put all the values, this is going from 0 to 10. This is e to the power of minus 0.03 t. This is 0.03. This is e to the power of minus 2 log of 1.05 t. Okay, dt plus 50,000 into e to the power of minus 0.03 into 10, because this is the survival probability for 10 year, and into 1.05 to the power of minus 10 and squared, so this becomes 1.05 to the power of minus 20. Now if you evaluate this, if you integrate this and everything, the answer comes out to be, I'm giving it to you directly, it comes out to be 2392933, okay, 128. So this is your answer. And if you try to calculate the variance using this, so this just becomes variance is equal to the EPV square minus EPV whole square. So this is just 2392933 minus the expectation was 43 498.914 squared. Okay, so this comes out to be, 500,777,609, or this can be written as 22,378 squared. Okay, so you can just solve this, you can integrate this like we did in the last part. taking this part outside, and then e to the power of minus at. The integral of this thing is just e to the power of minus at divided by minus a, right? So you will get this, and then you'll have to put the values, and then this solves. Okay, so simple, pretty easy. Okay, so this is the last question that I'm solving, and this is a question on uniform distributions of debt, that is UDD assumption. Okay, I've already solved a question on CFM. I'm solving a question on UDD, and these are the most important type of questions. You must have seen there are a lot of such questions in your core reading which ask you to calculate these mortalities based on UDD and CFM. Okay, so I'm just clearly solving this for you guys. So this is just P 55.753. Okay, and I have to calculate this using the UDD assumption. Now the criteria, as you know, that for applying CFM or UDD is that X should be an integer, okay, and T should either be an integer or it should be between 0 and 1. Okay, so it should either be an integer or it should be between 0 and 1. Then only we can evaluate such functions. Okay, so this one here, this x is not between it's not an integer, so let's try to convert this. I can write this as p55.75 0.25, right? So basically what I'm saying is, let's draw a number line and clarify this. I have to go from 55.75 to 3 steps ahead, so 58.75, right? The first step I'm taking is from 55 to 55.75 to 56. So I'm saying this is 0.25, 55.75. Next thing, I can actually go from 56 to 58 directly. Okay, because this value I can actually calculate directly. This would be 2p56, right? And the next step I'll take would be from 58 to 58.75. 58 0.75 p58. Okay, so this is how I can actually open this up. Now let's just see these three terms. Okay, here I can apply UDD directly, because for the reason that this is between 0 and 1, t is between 0 and 1, and x is an integer. Here also I can do that, here I cannot. Okay, this one needs to be adjusted a bit more. So p50 0.25 p 55.75, this can actually be written as p55 divided by p55 0.75. Now how did I get this? I'm going to show that to you. See, we are talking about going from, if I talk about going from 55 to 56, okay, I can divide it into two steps. Going from taking a step of 0.75 from 55 to 55.75, then taking a step of 0.25 here. Okay, from 55.75 to 56. So I can just basically say that p55 is equal to p55 0.75 into p55.75 going up till 0.25, and I had this term in that question. Okay, I had this one. See, I have this term. Okay, so in order to convert this, I can actually write this as the quotient of these two. So this implies that this term p55.75 0.25 is equal to p55 divided by, sending this downstairs there, so this is p55 and 0.75, right? So this is basically how you convert this, right? So that's how you do it. So this term becomes this, and the advantage with this is that this x term, it is integer here, here also it is integer, here it wasn't. Okay, so I just converted x into an integer, and this 0.75, it is between 0 and 1, so I can evaluate this too. This becomes 2p56 and this becomes 0.75 p58. Okay, now these are pretty straightforward. I just need to apply the UDD assumption. And if you remember the definition of UDD, it says that TQX is basically equal to T times QX for all the t's that are between 0 and 1. So for any non-integer value of t, I can actually use this fact that under UDD tqx is equal to t times qx. So I'm going to do that. Okay, so this p55, it just becomes, if I were to take the value directly from the tables, it is 1 minus q55, and q55 value is given in the tables. 0.75 p55 is 1 minus 0.75 q55. Okay, and this is 2 p56 becomes 2p56 becomes L58 over L56, right? That's what it becomes. And this part I can evaluate this as 1 minus 0.75 Q58. Okay. Now I need to apply this assumption UDD here. Okay. This just becomes 1 minus Q55. This becomes 1 minus. Now this is 0.75 Q55. So according to this becomes 0.75 times Q55, and Q55 value is given in the tables. Okay, this is L58 over L56, and this is 1 minus 0. Now this is 0.75 Q58. Now this becomes 0.75 times Q58. Pretty straightforward. Okay, so this is how you solve it. Now you can take all these values from the tables, and this is to be taken in this question from which table? Let's check the name of the table. The table is ELT 15 females. Okay, so you can take these values from ELT 15 females and you can put them here. Okay, so if you will put them here, I'll give you the final answer of this. See, basically this would come out to be 0.98274. Okay, you can actually check this and get it directly. So you can check this. You can put all these values here and you will get this answer. You have to take the q values and put them here, and the l values and put them here. Okay, and if you have any doubt, you can call me up. So I'm not doing all the table work, you can do the table work.